Okay, guys, welcome to the Last Minute Mechanics live stream. Can't believe this is the day before the last exam. I mean, that is pretty crazy. A levels are coming to an end for a lot of people right now. Most people have finished, I think, tomorrow, although maybe there are some people who are for normal, who've got chemistry. I think maybe chemistry is still going on as well. I wonder if it's not started. No, it should be started. Okay, I'm just going to double check this is connected, and then I'll just talk you through what we're going to do in today's session. So, maybe it's not working right now. Let's have a go. Okay, I think this has started. You can never really tell what is going on here. Hmm. Okay, I think we are live. It looks like I'm live. This is always the most stressful part of any live stream. Why does it not appear to be live? It says it's upcoming. No, I am live. Okay, this is right. Sorry, guys. Very, very stressful for me, but I am live now. There's nothing worse than doing live streaming and not having a clue whether you are actually live or not. If you know that, if you can just tell me that I'm here, that would be great. Everybody was saying I was late and it made me think maybe it's not even streaming. Anyway, I'm here now. This is it. This is the last live stream of this academic year. I kind of can't believe we're at that point already. Now, I'll talk you through about what we're going to do in today's session. So we are going to be doing 45 minutes, maybe a little bit longer. I've pre-selected some questions for mechanics. If you missed my statistics one yesterday, it is available in the live section on my channel. So if you go to Bicen Maths and if you go to the little tabs along the top, you can see live. And yeah, you can just go and do yesterday's one that was on statistics. And that was pretty good. I made up some of my own questions for that one. So you know, quite good questions. I think I made up stuff to do with normal distribution, binomial, things like that. I've just come straight out of an FP1 exam early today, and actually, it was a pretty good exam. I was the only person in the exam hall. If you go on my Instagram or if you go on the community page on YouTube, you can see a picture of me as the only person in the exam hall. Anyway, I'm not going to spend too much time chatting because we do just want to get on with some mechanics questions here. But if you do want some extra help with mechanics or statistics, there's a link in the description to get a £15 revision session, only 15 quid, much cheaper than loads of places where you might try and get revision, where you get 2 hours of a pre-recorded class that I did on Zoom a couple of months back. Plus, you get some additional questions and a video of me going through those questions. And the key thing is I pick up loads of strategies, not just do the questions, but I talk you through the way you should be thinking about doing these questions. Anyway, let's get started. First question that I want to look at is this question. Now, I've actually taken these questions from old spec papers and I've reduced the number of marks that are available. And the reason I've reduced the number of marks that are available is just because they don't tend to give out as many marks in the new spec as they did in the old spec kinds of questions. So, this one is about lifts. And I remember this question because this is from the 2018 paper. And the 2018 paper was when they were gearing up for the new style of mechanics. And so I've borrowed lots of questions from some of those bits of the old spec. And we'll see, I've reduced the number of marks for this kind of stuff. Okay. So it is the same maths. I know mechanics inside out. So the stuff I'm showing you today is all stuff that could come up. Some of it's taken from old spec maths, some of it's taken from international maths, but I've definitely made sure these are things that are related to what we've got. So we have here, it says a lift of mass 250 kilograms is being raised by a vertical cable attached to the top of the lift. A woman of mass 60 kilograms stands on the horizontal floor inside the lift as shown in figure 3. The lift ascends, meaning it's going up vertically with constant acceleration 2. So I'm immediately going to want to say that it's going up with constant acceleration 2. And it says there is a constant downwards resistance of magnitudes 100 newtons on the lift. By modeling the woman as a particle, find the magnitude of the normal reaction exerted by the floor of the lift on the woman. So we're now actually just going to be concentrating on just the woman. Here is the diagram of the person that's inside the lift, and she does not feel that 100 Newton resistance that's on the lift because that is only being felt by the lift. What she feels is her weight that is pulling her down, which is 60 G, and she feels the normal reaction, which is exerted from the floor of the lift pushing her upwards. Okay, so that is the normal reaction that she feels here. Now, normally you'd say these were balanced, but clearly it is accelerating. So because it's accelerating, we know that we're going to be using F equals ma. I'm going to be doing this in the upwards direction. So the resultant force is R minus 60g, and that is equal to her mass, which is 60, multiplied by the acceleration, which is 2. So R is 60 times 2 plus 60g. Just get that on the calculator. That's 120 plus 60 times 9.8, and that is 708 newtons. And if you wanted to, you could round that to two significant figures, which would be 710 newtons to two significant figures. However, I think it's perfectly fine to leave it at the 708 here, because that's like 3, okay? That's not really the tricky part of the question, but it was important to focus on just the woman in the lift, not the entire lift at this point. But part B is where things get a little bit more complex. It says the tension in the cable must not exceed 10,000 newtons for safety reasons, and the maximum upwards acceleration of the lift is 3 meters per second. A typical occupant of the lift is modeled as a particle of mass 75 kilograms, and the cable is modeled as a light and extensible string. There is still a constant downwards resistance of magnitude 100 newtons on the lift. Find the maximum number of typical occupants that can be safely carried in the lift when it is ascending with an acceleration of 3 meters per second. So this time we are going to be considering the lift and the people as one single particle. And we're definitely interested in something to do with the tension, because they told us that the tension has got to be less than 10,000 newtons. That's one of the key things that's in the question. So I'm just going to go through the bits that we have. We've been told that it's accelerating upwards it's ascending with an acceleration of 3. We know that there is the mass of the lift. Now, the mass of the lift is 250, so its weight is 250g. And we also know that there is some other people that are going to be inside the lift. Now, let's just say that there are n people. There are going to be n people. So the weight of n people would be 75n multiplied by g. There is still something else that's missing here. We also need to talk about the fact that there is a resistance of 100 newtons. So there is 100 newtons that is also coming against this lift that we've got. And we need to say that the tension has got to be less than 10,000. So I'm going to still do the same question as I did before. I'm going to do F equals ma, and I'm going to resolve it upwards. And my aim here is to find out what T is, find T in terms of n. So the resultant force is the force which is going up, which is T, minus the 250g, minus the 100, minus the 75n times by g, and that is equal to the total mass. We're considering this as one single thing. The total mass is 250 plus 75n. That's the mass of the lift, and then the mass of the n people who weigh 75 or have a mass of 75 kilograms each. And that's going to get multiplied by the acceleration, which is 3. So what I need to do now is just find out what T is equal to by putting everything all onto the other side. So T is going to be this thing times 3. So that's 750. 3 times 75 is 225. So that's 225n. Now I'm going to add the 250g. I'm going to add the 100, and I'm going to add the 75ng. So if I just add the constant terms are the 750 and the 250g and the 100. So I'll do 750, 250 times 9.8 and 100. That is 3,300. And then these are with n. So I have a 225 and a 75g. So I'll just do 225 plus 75 times g, which is 75 times 9.8. And that is 960n plus 960n. And then we just return to the original thing in the question, is that the tension cannot exceed 10,000. So this thing that we've got here has got to be less than 10,000. 3,300 plus 960n has got to be less than 10,000. And now it's just a case of solving that by doing 10,000 minus 3,300 and dividing it by 960. And we get that n has got to be less than 6.97916. So going back to answer the question, it says find the maximum number of occupants that can be carried safely. So I'll see if I can just squeeze it in at the end. The answer is 6 people, just down in the corner of this page, all on one page here. Because if n was 7 and you subbed 7 in here, the tension would be higher than 10,000. Maybe the tension in the cable would break. Maybe the cable would break and you got 7 people plummeting to the ground floor in a lift, which is not going to be very good. Okay, so that's why we did this kind of calculation this way. Now I think this would be I'll see if I can turn my mic up, but I don't know if I can turn it up much louder than this. Maybe you can just try it on. I've got the mic as loud as it can be for me. So let's try the next question. That was a nice, easy sort of forces one to start off with. I think if lifts came up, I can't imagine it coming up too crazily. So there it was, 708 or 710, and then 6 people. Okay, next question. I'm not going to tell you what the topic is. We'll see if we can identify this as we go. It says, in this question, I and J are horizontal unit vectors due east and due north, respectively. Two forces, F1 and F2 on a particle on particle P of mass 0.5 kilograms. Now we get told these two forces in I and J. Immediately, I'm going to write these in column vectors. So that's a 4 and a -6, and my F2 is a P and a Q that we've got. And it says, given that the resultant force is in the same direction as -2, -1. Okay, well, we know this. Resultant force, what have we got to do for a resultant force? Gives me a chance to have some water. And I can answer someone's question, why didn't I include the reaction of the people in B? Is because that's the reaction that the people are feeling. I'm considering the lift in the first part of the question and the people as though they have all merged into one single particle, almost like the mass of the people is blending into the mass of the lift. That's why I didn't do that. So resultant force, I'm going to add them together. So that's my 4, my -6, and my PQ. And it says that it's in the direction of -2, -1. In the direction of just means that it needs to be multiplied by some constant K. So that I get that 4 plus P is equal to, these top parts, is equal to -2K. And I get that -6 plus Q is equal to -K. So it's pretty obvious. If I want to now find out what K is equal to, or I want to double this and substitute it in, you basically just need to combine these by finding out what each part is. So I'm just going to find out what K is. K would be 6 minus Q. I just multiplied that by -1. And then I'm going to substitute this K that we have here into this part so that we end up with 4 plus P equals -2 lots of 6 minus Q. Nice, easy question. 4 plus P is -12 plus 2Q that we've got. And we just want to show the thing that's in the question. So we do actually end up with P minus 2Q is -12 minus 4, which is -16, which was the first part for those 3 marks that we've got. It then says, given that Q is equal to 3. So even if you couldn't do part A, you should definitely continue with doing part B as well, because it tells us for part B that Q is equal to 3. Well, if I know that Q is equal to 3, I can find out what P is, because P minus 2 times 3, P minus 6 is -16, which means that P is -10. So now actually I can go back and I can try and figure out what the magnitude of the acceleration is, because we know something. We know that the resultant force is equal to the mass times the acceleration. Now, the resultant force we worked out earlier on was these two things being added together. So the resultant force is 4 plus P and -6 plus Q. The mass they told us at the beginning of the question was 0.5, and the acceleration is the thing that we are looking for. So put this on a new page, but I'll just give myself a bit more space for a little bit longer. So I can now, substitute in that P is -10. So I get 4 minus 10, and I get -6 plus 3 because Q is 3. That's 0.5a. 4 minus 10, that's -6. -6 plus 3, that's -3. And that is equal to the acceleration. Oh, that's equal to 0.5 of the acceleration. So I will double both sides so that I get -12 minus 6. Now, that is not the end of the question because it asked us to find the magnitude of the acceleration. So it's asking for the magnitude of the acceleration. We are obviously going to have to do some Pythagoras on this. So I'll do the square root of my 12 squared and 6 squared. Where did I even put my calculator? Here it is. So that's root 144 plus 36. That's root 180 or 13.4 meters per second squared. So this was just a straight up like constant acceleration kind of question. And the clue was that it was going to be F equals ma because of the fact they told us about the mass in the question. Definitely no differentiation or integration with this question. And then we've got for part C, which I can also squeeze in on this page, find the direction of the acceleration of P, giving your answer as a bearing to the nearest degree. So I'm going to be using this factor here, that acceleration is -12 minus 6. And I always like to draw a dot to say where I'm starting from. And I'm going -12, so that's 12 to the left. And then I'm going -6, so that is 6 down. So I've gone 12 to the left and 6 down. And the angle that I'm eventually going to try and find out is the bearing, which means it's being measured from north and it's going to go all the way around like this. Now, there's lots of different ways of doing this. I think the way that my mind sees this is I will find out what theta is, and I will say that the bearing is going to be that whole thing, which is 270. That's three quarters of a turn minus theta. So I can just quickly figure out what theta is because tan theta is the opposite over the adjacent, which is 6/12. And obviously I want this in degrees, so I'm just going to make sure my calculator is in degrees mode, which it currently isn't after the further pure exam. So I'll do the inverse tan of a half, and I get 26 points. It's going to need it to the nearest degree, so I might as well just do this to the nearest degree, which is 27 degrees. So I shall just do 270, take away 27, and I get 240 degrees, 243 degrees for my bearing that I've got there, okay? So that is, again, a pretty straightforward question. These are going to ramp up in difficulty as we go through this session that we have. Let's try and double check that we got all of this right. Yeah, we got the root 180, which is the 13.4. I think I wrote 13.4. Yeah, I did. And we got the 243 degrees. They did it as a 180 plus a 63.4. Perfectly fine with my method that I did instead. Okay, we're going to try and identify what this topic is because it's still got something to do with mass this time. We do get told that the mass is 0.5. And so we think at some point I'm probably going to be doing F equals ma for this. And then it's telling us that it's under the action of a single force, F newtons. But that F is in bold there, which makes me think could be a variable force. We don't really know. It could be a vector force. And it says at time t seconds, the velocity is this. And I'm immediately going to write this velocity down. And I want to write it down in the sort of column form that I would be used to seeing for this. So the velocity is 4t minus 3t squared. And then we have t squared minus 8t minus 40. We're going to find the magnitude of f when t equals 3. Well, they told us earlier that the mass is 0.5. And so if I'm going to want to find out what f is equal to, what else am I going to be interested in finding if I'm trying to find the magnitude of the force and I know the mass and I have the velocity? What else could I think about doing? Yeah, perfect. We're just going to do acceleration, right? Obviously, we need to find out what acceleration is. Now, remind yourself when you have SUVAT, S, U, V, A, T, as you go down the list, you differentiate. As you go up the list, you integrate, okay? So I'm going to differentiate this, and I can just differentiate it by going straight into this. So that I get 4 minus 6t, that's differentiating the I part, and I get 2t minus 8 for this part here. I'm going to find the magnitude of f when t equals 3. So when t is equal to 3, the acceleration is 4 minus 18, because I've subbed in t as 3. 2 times 3 is 6, that's 6 minus 8. 4 minus 18, that's minus 14. And 6 minus 8 is minus 2. So if I want to find out what the force is, the force is the mass times by the acceleration. So that's 0.5 of minus 14 and minus 2. Well, that's just minus 7 and minus 1. And so the force, the magnitude of that force, do look out for that word magnitude. We will just have to do Pythagoras to the 7 and the 1. So that's going to be a 7 squared and a 1 squared, which is the square root of 50. Now, again, it's mechanics. I'm going to probably put that to 2 or 3 significant figures. So that is 7.07 newtons to 3 significant figures, okay? It then wants us to find the acceleration of p at the instant when it is moving in the direction of the vector minus I minus j. Now, when it's talking about it moving, what does that actually mean we want to look at? Do I want to look at acceleration? Do I want to have a look at velocity? Do I want to have a look at something else that I want here? Okay, and I can just keep labeling these parts. Yeah, I want to be looking at the velocity part. So I want to make sure that the velocity that I've got, because that's the way that it is moving, I want to make sure that that velocity is in the direction of the vector. In other words, a k minus 1 minus 1. So this means that 4t minus 3t squared is minus k, and that t squared minus 8t minus 40 is equal to minus k? Well, because they're both equal to minus k, these things here and here, they're going to be equal to each other. So that is 4t minus 3t squared is equal to t squared minus 8t minus 4t. So it's a quadratic. I am just going to add the 3t squared, so I get 4t squared, subtract the 4t, so I get minus 12t, and I get minus 40. And then they're going to expect you just to solve this on your quadratic solver. And they won't say this in mechanics, but if they ever said using algebra for a pure paper, we know that we would actually do it in the long way. So I'll put my 4 minus 12 and minus 40, and I get that t is equal to 5, or t is equal to minus 2. Obviously, we're not going to do this with a negative time here, so we've now got that t is equal to 5. Let's go back to the question. It says find the acceleration when it is moving in that direction. In other words, find the acceleration when t is equal to 5. So when t is equal to 5, the acceleration, going back to this expression we had at the top, would be 4 minus 6 times 5 and 2 times 5 minus 8. So that is minus 26 and 2 meters per second squared. Now, it didn't ask for the magnitude of the acceleration, so I would just leave it in this particular form here. I would not do this in a different kind of way for this bit. And I'll go to the last part of the question. It then says when t equals 1, p is at the point A, and when t is equal to 2, p is at the point B. Find in terms of I and j the vector A, B. So it seems like it's talking about position here. And if we go back to what we had in this part, we can see that if we want to go from the velocity up to where something is, we're going to do integration. And listen, if you have a variable acceleration question, it is highly likely one part of the question will be differentiation and one will be integration, especially if they start off by giving you the velocity. So let's continue with this part of the question, and we're going to do the integration part. So for part B, I'm going to just jot this down so we don't have to keep flicking. I don't have to keep looking back and forth. We get the 4t minus 3t squared, the t squared minus 8t minus 40, and I'm going to integrate this. Now, I could use the letter S that we had. Oh, I could use the letter S, or I could use the letter R. It doesn't really matter. I'm going to use the letter R just because we're doing vectors. So when I integrate this, it will be a 2t squared and a minus t cubed. I'll do the constant afterwards. You can do it now or you can do it after. I like to do it after. This will integrate to a third t cubed minus 4t squared minus 40t. And then there is some constant that comes afterwards, which is c. Now, actually, this constant is going to get cancelled out because we're going to try and now find out the vector AB. And we know that the vector AB, from our pure knowledge, is the second letter minus the first letter. So it's the position vector of B minus the position vector of A. Now, the position vector of B, this is when t is equal to 2, and this is when t is equal to 1. So what I'm going to do is substitute when t is equal to 2 into all of this, and there'll be a plus c. And I'll substitute t equals 1 into all this, and there'll be another plus c. But those c's are going to cancel out because they're going to have a c in the first part and a c getting subtracted. So this actually won't matter. We don't actually need to find the value of c here. So I'm just going to sub in 2. So that's a 2 times 2 squared minus 2 cubed. We have a third times 2 cubed minus 4 times 2 squared minus 40 times 2. And from that, I'm going to subtract when I put 1 in. Well, 1's really easy. That's just a 2 minus 1 and a third minus 4 minus 40. So I know that looks kind of complex of all those different parts, but I'm actually just going to go on my calculator. I'm going to type that whole calculation as one single bit that I have. So I have 2 times 2 squared minus 2 cubed. Well, that's just going to be 0. And I'm going to subtract from this, which is 1. So I think I've done this right. I've got a minus 1 for that top bit. And then I'm going to do this but a little bit more slowly. So I've got my 2 cubed divided by 3 minus 4 times 2 squared minus 40 times 2. That's minus 280 over 3. And then I'm going to be subtracting this thing, which is a third minus 4 minus 40. I'm subtracting a negative 131 over 3. So my final answer is minus 1. And that's minus 280 over 3 plus 131 over 3. And that's minus 149 over 3. Now, that doesn't sound great, so I'm not really sure if I've made a mistake somewhere. Nope, it is the correct answer. We do have the minus I and the minus 149 over 3 for that part, okay? So they do it in I and J. If you want to at the end, you could write this as minus I minus 149 over 3J, but they should accept it in both of these forms that we've got, okay? So I just wanted to do that so that so far what we've done is we have done a forces question to start off with. We've then had a vectors question where there was like a constant acceleration. We then had a vectors question where there was differentiation and integration. And now we're getting on to the proper kinds of stuff, which is stuff to do with moments. And they've had a question on this every single year. So we need to be prepared for these kinds of questions. And in these kinds of questions, there is a pretty solid approach that you should be applying to every single one of these. Okay. The approach is always going to be to do these three things. One is to take moments. We're then going to resolve up and down, and we're going to resolve left and right. And the reason this is hard is because the diagrams sort of feel a little bit they feel quite complicated. So I'm going to just copy out this diagram because I don't have it printed for me. So it says here that we've got a uniform rod, AB, has length 4 meters. Well, I'll use that in just a second, and has weight 50 newtons. So I'm immediately going to add on here that there's 50, but I don't need to put a 50G. Why don't I need to put the G with that? Okay, good. So, yeah, we obviously don't need to put the G with it because it's already told us the weight. It didn't say it was the mass. It says it's held in equilibrium at an angle alpha to the ground. So I'm going to write that here. By a light inextensible cable attached to the rod at B as shown in figure 2. So I'm going to now show that there is a force here which has got tension in it. And it says the cable and the rod lie in the same vertical plane, which means it's just not like a wonky angle or anything, so you don't need to use that. And the cable is perpendicular to the rod. The tension in the cable is T newtons, given that sine alpha is 3/5. Right, as soon as I know that sine alpha is 3/5, which I probably write as 0.6 these days, I just find it easier to substitute in. You can tell me what cos alpha is equal to. So I'll give you a chance to tell me what cos alpha is equal to. Yep. Cos alpha is 4/5, which is 0.8. And should I need it, tan alpha is 3/4 or 0.75 for this one, if I need to use these things. Now, we're going to go and do those three parts in the question, but the first one just says to show that t is equal to 20. Across the question, you will do all three of these things, but I think we're just going to start off with taking moments, because that's probably the one that's going to give us t very, very quickly. So I'm going to start off by taking moments, and the best place to take moments is nearly always at the bottom. I've realized I haven't even put the other forces. Of course, we've got a normal reaction here, and because the rod is going to want to slip, I don't know which way around my camera is, it's going to want to slip to that direction. It's going to want to move to the left, which means that the friction is actually going to the right like this. So if I take moments about A, the R and the mu R are both going through A, so they won't be included. This is a 2 and a 2 because of the fact the rod is a length 4 and it's a uniform rod, so it's 2 on either side. And we know this is perpendicular. So the moments is really, really easy for this one because we just have the T force is the thing that's trying to make it move in the anti-clockwise direction if we imagined it being pivoted at A. And the 50 is the force that's trying to make it go in the clockwise direction. So I'm going to say that T multiplied by 4 multiplied by T, because this T force that we've got here, that force, the perpendicular distance, is just 4. Nothing needs to be resolved for this. But for the 50, we want to find out the perpendicular distance from that point to the force, which is this part that's running along the bottom of the triangle. And that part running along the bottom of the triangle is to do with this little triangle that we have here, where that's an alpha and that's a 2, and that's the distance. That distance is 2 cos alpha. It's 2 cos alpha. So I can now say that it's going to be my force, which is 50, multiplied by my perpendicular distance, which is 2 cos alpha. So 4t is, what's that? 50 times 2, that's 100, times by cos alpha, which is 0.8. So 4t, haven't even touched a calculator, is 80. And so t is equal to 20. All these questions, you're going to be doing all of these parts. All of these things. So you're going to resolve and you're going to resolve. It says, given also that the rod is in limiting equilibrium. Well, if it's in limiting equilibrium, what do we know if it is in limiting equilibrium? And it's something to do with those forces at the other end. And whilst you type that, I'm going to answer someone's question. Why is the friction going to the right? Well, this T force that we've got, it's trying to pull the rod to the left, which means the bottom is going to want to slide to the left, which means the friction is going to the right. Good. Limiting equilibrium is that friction has reached its maximum. So we can say that friction is equal to mu r that we've got. So we're going to find the value of the coefficient of friction between the rod and the ground. Well, I guess what needs to be doing here is just resolving forces up and down. That is going up, that is going down, that is going to the right. This one is going at a funny angle. So we need to split it into only things that are going up and things that are going across. Now, I know that it goes up and across because this arrow starts from here and it finishes at this end. So I have to do that same pathway. I have to go from the start point up and left. It follows the direction of the arrow just like it does with vectors, okay? Now, if this angle is alpha, this angle is alpha. And the reason it kind of works with this, I'm not going to do this in too much detail, but if this is alpha, you can imagine that this one at the top as a Z angle would be 90 minus alpha. No, would be alpha as well, excuse me, which means that one would be 90 minus alpha, which means that one would be alpha. So as I annotate these, this is going to be my T cos alpha. This is going to be my T sine alpha. And I'm now going to do the next thing, which is to do the resolving up and down. So when I resolve up and down, I get that T cos alpha is going up, as is R, and that is equal to 50. Now T is 20, so that's 20 times by cos alpha, which is 0.8, plus R, which is equal to 50. So I will do 50 minus 20 times by 0.8, which is 34. So R is 34. And this is a pretty straightforward one. If you want to see a harder version of these questions, I do some more challenging ones in the revision session that I did on Zoom that you can access through the link in the description. And then if we do left and right, the only thing that is going left and right is the T sine alpha to the left and the mu r to the right. Now, T is 20, sine alpha is 0.6, mu is the thing we're looking for, and r is 34. So my final step to find out what mu is equal to do is to do my 20 times by 0.6 and to divide that by 34 so that we get that mu is 6 over 17. And if we want to give that to three significant figures, that is 0.353 to three significant figures, but they'd probably accept it as a fraction as well for this question. Okay, so people are saying, where did the 2 cos alpha come from? That is because when you're doing the moments, you're always trying to find out the shortest distance between the line of action of the force and the place that you're taking moments. So here is the line of action of the force, and I want to find that shortest distance. So I'm using this triangle where I know the hypotenuse is 2 and the angle is alpha. Okay? Now, there are more challenging ones of these questions. So that one is a pretty straight up kind of one. There's no like variables, no unknown variables in this question. But I'll double check that we did get this correct. We have 6 over 17. Yeah, so they actually don't even have it rounded. Oh, they do have it rounded here as the 0.35. Okay. So the last couple of questions that we're going to be doing, I think we've got one more after this one, is projectiles. Projectiles is, I would go as close to say that projectiles is as close to being a guaranteed topic as possible. I have seen projectiles every single year. I know what's going to happen now. It probably won't come up as I'm saying this, but projectiles is a guaranteed topic as far as I'm concerned. And actually, this question is from an old spec, but there is a question incredibly similar to this in the new spec. So as the old spec was kind of trailing off, it inspired examiners to start coming up with new ideas. And this is this question that we've got. I have reduced the number of marks. So this is quite similar to the number of marks we would expect to see. Okay. What have we got here? It says the point A and B lie 40 meters apart on horizontal ground. That's really important. At time t equals 0, the particles P and Q are projected in the same vertical plane, meaning like directly towards each other, containing AB and moving freely under gravity. Particle P is projected from O with speed 30 at 60 degrees to AB, and particle Q is projected from B with speed q meters per second at angle theta to BA as shown in figure 4. At time t equal 2 seconds, P and Q collide. Okay, so this is a pretty nice question. I like this. So we've got this particle, which is over at A, that's got 60 and 30. And then over at the other end, we've got this other particle, which has got speed q and angle theta. And the way that this one is traveling, it's going to go like this. And then q is traveling like this. And at time t equals 2 seconds, they collide with each other. Okay, so this collision occurs when t is equal to 2. So we know more about this one. I think we should try and figure out where is p at t equals 2. Where is p at t equals 2? Because if I know where p is at t equals 2, I just need to make sure that q goes to that point as well. Okay? Yeah, good. We're going to see something that the distance along the bottom has got to sum to 40. That's going to be an important feature that we've got there. So let's actually figure out where is p at t equals 2. Well, the speeds, as we resolve it here and here, we're going to have my 30 sine 60 for the vertical speed and my 30 cos 60 for the horizontal speed. And I like to start off by considering my horizontal motion. You know, for projectiles, you've got to consider the vertical and horizontal motion. For horizontal motion, we're going to find out where it is. Now, distance equals speed times time. The speed is the 30 cos 60. That's its horizontal speed. And the time is 2. Now, cos 60 is a half. So this is just going to be 30 meters. So my diagram is not very well drawn. It actually is probably more over here that it is going to get to. It's going to get to 30 meters. So that means this distance is 30 meters, which means that Q's distance is 10 meters. So let's have a look at the horizontal motion. The horizontal motion, and we're going to do this time for particle Q. Now we know that the distance has got to be 10 this time. And the reason it's 10 is because sorry, that was a bit off the page. The 30 and the 10 have to add up to the 40. So if this one has traveled for 30 meters to get to the collision point, the other one has traveled for 10 meters. And distance equals speed times time. So we get that 10 is equal to, well, Q that we've got, we have our Q cos theta and our Q sine theta. The speed is Q cos theta and the time is 2, which means that Q cos theta is 10 divided by 2, which is 5. Okay, so we're starting to build up to this kind of bits. We're now going to do the vertical motion. Vertical motion for P, and then afterwards we'll do the vertical motion of Q. Now the initial speed for P is going up in this part. So I'm going to do upwards as my positive direction for both of these. It's always a good idea to try and indicate this. So I'll say that's my 30 sine 60. We know that time is 2. We know that the acceleration is minus g, or minus 9.8. And remember, we're trying to think out where actually P is. So what is the displacement? Where has P got to? So that I got a bit more space. The equation that connects those. What's the equation that can, it's kind of hard to type, but we're going to have S equals UT plus a half AT squared. So S equals UT plus a half AT squared. So S is equal to this times 2. So that's 30 sine 60 multiplied by 2 plus a half A. Half of A is 4.9 times by T squared. So on my calculator, that is 30 sine 60 times 2 minus 4.9 times 2 squared. And we get 32.3615222 like this, okay? Now, if I do the vertical motion for Q, I get that the initial speed is Q sine theta, and the time is 2. The acceleration is minus 9.8, and I know that the distance that it's going to be traveling is this part that we've got, okay? I have the same distance. I want to check I've just put that in my calculator correctly. 30 sine 60 times 2 minus 4.9 times 2 squared. Yep. So that is the thing. I've still got my calculator, 32.3615. And we're going to use that same thing to try and find out, is there anything I can do for this? S equals UT plus a half AT squared. So I'm going to say that S equals these two things multiplied, which is 2Q sine theta plus a half A times by T squared. So I'm going to take that S and I'm going to add this thing on here. So I've got my 32.36 that's still on my calculator. I'll add 4.9 times 2 squared. And I'm going to divide it by 2 so that I have just q sine theta by itself, so that I get 15 root 3 is q sine theta. Oh, this is probably more than 5 marks, to be honest. But I've got that this is what my q cos theta is. This is what my q sine theta is. What am I going to do? How can I find out q and theta with these equations? This should definitely be more than 5, I'd say. What should I do with these 2 equations? I could divide them. Yeah, let's divide them. So I'll do this one's number 1 and this one's number 2. I'll do number 1 divided by number 2 so that I get tan theta is 15 root 3 over 5. That'll tell me what theta is. So I'll do 15 root 3 over 5, inverse tan the answer, and I get that theta is 79.1 degrees. And then I can just use that to find out what q is. So I could say that q is 5 divided by cos of 79.1. So I will do the cos of that answer. I'll do 5 divided by that. And I get that q is 26.5 meters per second. And then this is where I want to double check before I do the next part of the question that I've not gone completely off course. So no, I got the 79.1 and the 26.5. Wouldn't it be amazing if you could check your answers as you were going in the exam like that? And then it says, find the speed of p at the instant before it collides with q. I can probably fit this on the page here. So we're going to try and find out the speed of p. Now, the speed of p is 2 things. We have the horizontal speed of p, we have the vertical speed of p, and overall, we have the speed of p. Now, the horizontal speed, we actually worked out here. It doesn't change. It is 30 cos 60. 30 cos 60 goes along the bottom. And you can think how you're going to find out what v is. You're going to do Pythagoras. So I need to find out what this part is here. I'm not going to call this, I'll call this one v2. Okay? So I need to find out the vertical speed. I want the vertical speed at t equals 2. And I'm going to do that by using v equals u plus at. So I'll do v equals u, which is 30 sine 60. That's v equals u plus the acceleration, which is minus 9.8 times 2. So that should say minus 9.8 times 2. 30 sine 60 minus 9.8 times 2. And we get that v is 6.3807. So this part is 6.3807. So my last thing to find out the hypotenuse then is to do Pythagoras with these 2 values. So it's my 6.3807 squared and my 30 cos 60 squared. So I'll square that and I will add on my 30 cos 60 squared, square root the answer, and I get 16.3 meters per second. I don't know why I tried to squeeze that in that tiny space. Probably not a good idea. But we do end up with that 16.3 in the mark scheme. So I think we've probably got time to do one more question, and then I'm going to look a little bit more in the chat and be able to answer some of these questions. But they have asked this in an old spec. They've asked this in 2019. If they asked us to criticize something about the model, I suppose we could talk about the dimensions of the particles that we don't know. If it's 40 meters here, we might need to take into account the size of the particles. We might take into account wind. We might take into account the speed of the spin of the ball. There's lots of different things about the modeling that we could do. Okay. So last question that we're going to have a look at here is this one. 8 marks. They originally awarded this 10 marks. I've kind of taken this down to 8 marks. Now, I don't know about you, but I don't normally draw my diagrams that way around. I normally draw my diagrams this way around. And so I think I'm going to find it easier if I actually do draw the diagram in the way that I like, the more traditional way of the slope going like this. It's not going to change anything about the question. I've seen people try and draw this diagram the other way around, and their forces just get crazy. So if you need to ever flip a diagram, you can do. And I'm probably not going to do it with a circle. I prefer to do it with a box. I'm not going to get punished for that at all, okay? So this is the 30 degrees, and the P is coming from this angle like this. And it says that the angle to the horizontal is 20. So that must mean that this overall angle is going to be 50 degrees. Quite unusual. They normally just have it as like a horizontal and a vertical one like this, but this one's kind of tilted up even more. So there must be a 50 for that part for P. I haven't even read the question. This is classic me. Just do the maths before even reading the question. It tells us the mass is 2g. It's on a rough plane. The plane is inclined to the horizontal at 30 degrees. The coefficient of friction is a quarter. The particle is held in equilibrium by a force of magnitude p newtons. So I'm definitely going to want to put the normal reaction here. And it says the force makes an angle of 20 degrees with the horizontal and acts in a vertical plane, blah, 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 blah. Ooh, this is the interesting part. Find the least possible value of P. Okay, the least possible value. So this is where you want to think, what's going to happen next? What would happen if P pushed a little bit less? If it pushed even less, because we're looking at the least possible value, what would happen to this box? I can see people in the chat saying, why did I flip the diagram? I just am used to drawing my diagrams this way, so I flipped it. If you want to keep it the original way, I don't mind. However you want to do it is absolutely fine. So what would happen if I made P get a little bit smaller? It's going to start sliding down the slope. I'm saying that coming up. It's going to start sliding down the slope, which then tells you friction must be going up the slope. And friction is mu, which is a quarter, times by r, like this. So the last thing I need to do for this is to resolve all of the forces so they're going in directions that I'm happy with. So I'm going to take the 2g and I'm going to split it into these two forces where that angle is 30. That's my 2g cos 30, and that's my 2g sine 30. And then I'm going to take the P force and I'm going to split it up into a force here and a force here like this, where I have my P sine 50 and I have my P cos 50 like this. Be careful that it's 50 and not 30 though, okay? Now, a student of mine who was in the first year 13 class I ever taught, Wahida Begum, she's now a maths teacher. And she came up with this. I don't know where she saw it. I don't know if she made it up herself, but she came up with this, and she's always been one of my best students of all time. So if for some reason she would ever be watching this, shout out to Wahida, of course. So I'm going to take all these forces and I'm going to put them on this diagram. It can make it a bit easier to see what's going on if you find these force diagrams confusing. So I have the R force. I have going to the right, I have a quarter R, and there's this P cos 50. Now, as soon as I do the P cos 50, I like to put its matching one, which is the P sine 50. Obviously, you don't need to put P on because you've now put it in its split up form. And I think the only other force that I've now got to do is the 2G, which is my 2G cos 30. And then coming out to the left, I have my 2G sine 30. And it's in equilibrium. So because it's in equilibrium, I know that these forces are equal, and I know that these forces are equal to each other. And this will be the last question, so you can finish up after this. So I'm going to say, resolving in this direction, R is 2G cos 30 plus P sine 50. And then resolving in the left and right direction, or sort of up and down the slope direction, we get that 2G sine 30 is equal to a quarter R plus P cos 50. Now, I know what R is, so I can just take this and substitute it in here and find out what P is. This is worth all of the marks, all this stuff that you've done here. These two things are going to be worth the bulk of these 8 marks. This is probably worth 3, maybe 2 or 3. That's worth a mark for doing, a quarter R is worth a mark. So it's 1, 2, 3, 4, 5, 6. Easily going to get ourselves up to 8 marks. So I'm going to take this R here and substitute it in there. And then I'm just going to put it all in my calculator and we're done. So 2G sine 30 is equal to a quarter of 2G cos 30 plus P sine 50 plus P cos 50. Just about squeeze that in on the diagram there. So 2G sine 30 is a quarter of 2G. That's a half G cos 30. Let's not switch that up. Plus a quarter P sine 50 plus P cos 50. So I'll do 2G sine 30. It's just solving an equation now. Minus a half G cos 30 is equal to, if I take out a factor of P, I get a quarter sine 50 plus cos 50. And all that's left to do is to do 2G sine 30 and minus a half G cos 30 divided by a quarter sine 50 plus cos 50. And while you are watching me type this in a calculator, you can tell me which one do you prefer between stats and mechanics. I'd love to see on the chat which ones people prefer. So I'm going to do my 2g sine 30 minus a half g cos 30 all over a quarter sine 50 plus cos 50. Basically saying mechanics there. This I did not intend to have this as the last question. But the value of P is 6.66 newtons to 3 significant figures. Listen, this is not a sign. This is not a sign telling us that tomorrow is going to be a hellish paper, I promise. Okay. But 6.66. That's what we ended with. I know it's the right answer because I remember when I looked at this question yesterday, I was like, I can't believe I've picked a question that has got 666 as the answer for this. Okay. Seems like mechanics was the most important, the most popular one there. Okay. So that's it. That's my last live stream of the 2024 exam season. There are still a few things you might like to keep up with. I will do my reaction video after tomorrow's paper, kind of just saying what I thought of the whole thing, really just kind of talking about how this whole experience has been. And then I have got another exam on Friday. And then on Monday, I'd love it if you stick around on my channel because on Monday I have got 4 exams. And the 4 exams that I've got, are 6 hours and they're all of the hardest further maths exams. They're all on Monday. So if you want to see me doing a video on Monday after I finish those 4 exams, you will see me. I mean, the bags under my eyes are big enough already, but I am going to look an absolute state at the end of that Monday. And I will just do like a final video kind of saying how I found this whole experience of doing the exams and hopefully what I've learned from it and hopefully what I'll be able to provide for students in the future that will give them an even better experience. Okay. Decision I am not looking forward to. Decision is probably I am going to do a tier ranking of all of the different modules, but decision I'm just so bad. I'm just so bad at keeping like the detail that you need for it. Now, of course, this doesn't cover everything in mechanics. There's still like a little bit else here and there. If you want to go and look at my statistics live stream, similar vibe to this, apart from I wrote the questions. So I'd love it if people wanted to go and have a look at that. And like I said, if you do want some more sort of guided revision, there is a recording of these 2 revision classes that I did. They're available in the link in the description. They're only 15 quid. So if you just want something to kind of focus your revision, potentially before your last exam of A-levels, then yeah, it's right there. But only if you want it. I don't like to push anything on anyone because it's just, most of the time I like you to just come along and enjoy these live streams that we've got. Okay, if there are any other things that we've got here, I'm just going to see if there's any questions. Do you get both papers at the same time? Yeah, you do get given both papers at the beginning, so you can choose which way around you want to do this. Any other questions before we finish up? Oh, I'm so tired after the further pure on exam as well. Can I explain projectile vertical motion? What is different if it's positive or negative? I'm confused. So I basically, for projectile vertical motion, I always set upwards as the positive direction and just go from there. Friction is going up in this question because we've said that P was the least value that it could be. If P was any less, it's going to slip down, which is why friction is going up. If they said the maximum value of P, the value of friction would be on the other side because it would be about to move up the slope instead. In terms of predictions, I'm expecting to see moments and projectiles. I'm expecting to see differentiation and integration for variable stuff. That's pretty much guaranteed that those things are going to be there. Anyway, I'm going to wrap this up now. Just wanted to say a huge thank you for coming along to this live stream, supporting me with my channel over whether it's been the last few days or the last couple of years. It's just great. Just love people getting to learn maths from me on YouTube. Never thought I'd be able to get to do this. So it's an absolute pleasure for me, guys. Just want to say, yeah, good luck. That's it from me. No more live streams, but you will hear from me after the reaction tomorrow's paper, reaction on Monday's paper, and then there'll be something on results day. Of course, I'm going to want to share what marks I've got. Have I got any full marks? That's the big question for me. I'm really hoping I have done. Okay, guys, have a good evening. Have a revision-filled evening, or maybe take a break if you need to. And I will see you, hopefully, soon. Bye, guys.